Welcome to this special bonus episode of the Passive House podcast. I'm Zach Semke, Director of Passive House Accelerator, and we're pleased to be sharing a series of bonus episodes recorded at the International Passive House Conference 2023 in Wiesbaden, Germany. These interviews were made possible by support from Icon Windows and Doors, Inotech Windows and Doors, Intelligent Membranes, Minitaire, and Proclima. Please enjoy this bonus episode.
Well, my name is Tomas. I have been last 7 years at PHI.
Yep.
And I have been working on developing algorithms for heat pumps in PHPP. And also the whole certification scheme, basically, for the heat pumps.
Yeah.
And what I do nowadays is certify the heat pumps and ventilation units.
What's your background? How did you get into that?
Well, I have been studying civil engineering.
Yeah.
At the university, and I have always been interested in building services.
Right.
And somehow then I found out about passive house concept. And so when I finished my PhD study in Denmark, it was kind of like natural step to, I thought like it would be cool now to work with people who developed this idea. No?
Yeah.
So I just contacted people in Darmstadt, and
were you originally from Denmark?
So I'm from Czech Republic, but I've been studying in Denmark.
Right. What took you to Denmark?
Well, that was the Erasmus program, if you have heard about. No. Well, it's like an exchange program when you study.
Right.
So
you got the chance to go there.
You just go there or there to see the world.
And civil engineering. So not bridges and roads and
that's
structure.
The point. I mean, that was really annoying for me, because when you study civil engineering, you need to take all of those courses like bridges, like all of this, and I didn't really enjoy that so much, because for me, you just follow all of those error codes, and it's like there is not so much freedom, I think, like in building services, because you have much more freedom what you choose. For ventilation or heating or stuff like that. But when you design a column made of concrete, it's like usually somebody else tells you the design, how it should look like, and you calculate all of the statics. But you follow like a very strict. That was my feeling. It's very strict way how to do it. Right?
Sure.
And building services was more like even more technical.
A lot of building services engineers tend to be mechanical engineers.
Yeah. So it's kind of like. I studied both.
And what was your PhD?
One more time, please.
What, your PhD?
Yeah, it was also about heating and cooling systems, and it was radiative heating and cooling systems. It was made of capillary tubes, if you have ever heard about it. It's very tiny tubes. And it was integrated into a high-performance concrete wall. So very thin wall made of high-performance concrete. And it was made like prefabricated elements.
With liquid going through or air?
No, water. So
water.
It's a water system. Radiant water.
For both cooling and heating?
Well, I mean, it's a water system. So if you have a heat pump which can heat and cool, so you simply do both, right? It's we integrated this into the floor, ceiling, and also into the walls. So the idea was it's suitable, for example, when you have like a classroom which is very densely occupied with students, you have a higher cooling loads, right? And if you want to cool that space with air, it's not so easy to distribute that cold or that energy, right, into the room without causing discomfort. And because what we feel is basically when we stand here in this room, you don't feel only room temperature, right? It's about 50-50 with the surface temperature. So it's kind of, And we integrated also, it was like a double ceiling construction. So you put the air, you supplied fresh air into that space between ceiling and suspended ceiling. There was also this cooling, right? So the air was touching the surface, got colder, and then the air was distributed through the whole area of the ceiling to the room.
Does that air movement help reduce condensation as well? Because that would be a risk. Is that a risk for...
Well, I mean, the air movement itself doesn't reduce the condensation, but I mean...
Is that a risk, though, when you're using capillary type systems?
No, that was the idea cooling? Also. Of course, when you go with radiant cooling into the humid climates, you can run into this situation that you will have condensation on the surface.
Yep.
But that's why in this particular project, the idea was that we have it in all surfaces in the room.
Right.
So in order to deliver a certain amount of cooling energy into the room, you don't need to go with your temperature of the surface so low.
Right.
Right? Because you so in comparison with floor, let's say, or ceiling, when you activate also the walls, you have much more space. So I mean, your temperature you need is much higher to achieve the same comfort in the room.
Right.
And so that was the idea.
Yeah. And so had you learned about Passive House growing up in Czech Republic? Was Passive House known there?
I mean, I think yes, I have, and that was actually time when I was kind of like frustrated, like why they are doing it in Germany and I have not heard about that in Czech.
Yeah.
But we have also Passive House Institute, kind of, they don't work directly with us, I think, at the moment. I'm not sure. But so there is something going on in Czech Republic as well.
And what about Denmark?
Did
you come across it in Denmark?
Yes, but in Denmark, the thing is that they already have their, like, state already has a standard, which is so good. Like, it's close to Passive House, I think, nowadays.
Right.
So nobody...
Because, I mean, that's pretty extreme climate to start with, right? So
no, it's actually not. People think that it's like, it's north, right?
Yeah.
The country, so people think it's very cold, but it's actually not, because it's close to the sea. And so even in January you have like sometimes 5 degrees Celsius temperature, so it's rather mild actually.
Right.
You have a lower temperature in Germany compared to Denmark, I think.
Okay. But they've had a good building code, rules.
They have been implemented. I think it started sooner than somewhere else, so they were cautious more about this issue.
Right.
And in the meantime, I think the standard, the building standard is so strong that, I mean, when it's close to Passive House, then somehow, when anybody needs to do it anyway, because states tells you, Passive House, it's difficult for Passive House to compete with that, because it's actually Passive House in principle.
The gap's pretty small.
I mean, they just saw, okay, this works, so they implemented it finally.
Yeah.
And at the end of the day, I mean, that's what we aim for. I mean, we would like to see that people build this worldwide, right?
So tell us about what's going on with heat pumps now. What are you seeing in heat pump technology? Yeah,
I mean, with heat pumps, we have a bit the difficulties. Challenge for me, or in general, we have difficulties to get the right data, so we can model it in PHPP. We just need additional data usually for part load operation.
Right.
The issue with heat pumps in general is that they are over-dimensioned for the passive houses.
Okay.
Or let's say example for a single family home.
Yeah.
It's difficult to get the heat pump which is right size. It's usually over-dimensioned. And when you install the over-dimensioned heat pump, it will obviously not run, usually most of the time it will run in the part load. So let's say when it's turned on, it will go like 30% or 40% of its nominal capacity, right?
Yep.
Cooling or heating capacity.
Yeah.
And the thing is that heat pump has then lower performance than when it runs in nominal.
So it's got a nominal efficiency where it's performing at its
so let's say
range.
that in nominal, like 100% nominal power, it has COP of 5.
Right.
And then for the units with inverter technology, you know what that is?
So that can ramp up and
down.
That
regulates like that, because you have two types of heat pumps, on-off.
Yep.
So either you run it 100% of its capacity or you switch it off.
Yeah.
But those heat pumps are, I mean, you can barely find those heat pumps on the market.
That's sort of the
nowadays.
older technology.
It's the old technology.
Yeah.
Because it has, the idea was, okay, if we use this inverter technology, which is like electronic, which modulate the speed of the compressor, we can adjust the power output of the heat pump to the load of the building in a real time.
Yeah.
Yes, and it somehow also works like this, but there is a limit where you can, when this inverter can operate.
Yep.
And from my measurements I have done, what I have found out was when you go below, depending on the heat pump, right? Each producer has it a bit different. But if you go like below 40% or 30% of the nominal load, the heat pump starts to go to on-off operation anyway.
Right.
Even when it is equipped with the inverter technology.
Right, so you're not getting the benefits of an inverter.
At that range of 0 to, let's say, 30%, you don't have any benefit of inverter.
Right.
So, and the performance is really, it goes like, if it is 5 in nominal capacity, it could be, if you go to 20%, so you have like 20% part load operation, I don't know, it could be like 2 or even less, depending on the heat pump.
Right.
And if you have the data, what you have in data sheet, just for the nominal value, you see, it's like, it's nice to have, I mean, because the reason why they do just those values, I think, is that it's not completely useless. You still can use this scheme to compare units between each other, right?
Right.
And you have some idea which one is better or not.
Yeah.
And this is, I think, how those standards to test heat pumps are usually developed. That's the goal. Because you have this like a label, right? You have this energy label.
And those are based on certain operating parameters, aren't they? So they have to be operating a certain outside temperature and an indoor range.
Exactly.
But they're still sort of optimized.
Well, I mean, the thing is, some of those, we simply need more. Those are good if you want to compare products between each other.
Right.
But if you want to model your house in different climates around the world through the whole year, you need more data. I need those data in part load, right? Because as I mentioned before, those heat pumps are often too big for passive houses, right?
Yeah.
And they will run in part load, so we need the real data. It's like, it doesn't bring us farther when I use COP5, but I know it will run most of the time with, question is like 2, 3, maybe even less, you know.
And that number
we need more realistic data. So what we need for passive house certification, we need those data in part load. Those are very often missing. And it's difficult for me to get the producers also on the board because
we are asking them to produce lower numbers.
Somehow, yes.
Less attractive numbers.
Yeah, but that's the case only if you compare it to the different scheme, right? You should, but that's the issue. Like, you should always explain to the client, okay, look, in the data sheet here is a lower value, but you cannot compare those two. Another challenge with heat pumps is that I make an example now to compare it with small ventilation units.
Yeah.
Often the producer of small ventilation units is a small company. Very often you can actually contact directly the owner.
Yeah.
Not only director but owner. It's a one person. So it's easy to get in touch with the right person, with decision maker, so to say.
Yeah.
But in case of heat pumps, those are usually companies which are very large worldwide. And so you spend like months trying to find the right person, and when you think you have found him already, he has left the company or something like this. You never get to the point where somebody can make actually the decision. So I must admit I have a bit struggled to get people on board, but
so do you always rely on the manufacturers to supply the data, or is there testing that you can do with units
The testing needs to be done by third-party lab,
right?
Independent from PHI and independent from producer. That's the idea. That's very important for us, actually, that we stay independent, right? We are just the body which evaluates the results at the end of the day. And if the performance is right, they get the certificate.
So part of your challenge is convincing the the company that they've got to get that tested
Yeah,
to a standard that you specify
yes.
at their cost.
Yes.
And then provide you with the data.
Yes.
Yeah, right.
Yep.
But if they want to be, well, the benefit to them is that they get to then be in PHPP. Is that?
Yeah. I mean, the benefits you get when you have a certified product is, one of the biggest benefit I see is that your unit is in PHPP, but it's also on the database on our website, and so you have like a values available.
Yeah.
And because very often, I mean, it's a hassle for architects to, call producers and try to get the data we ask them to get.
Yeah.
And they don't even have those data very often.
You, then
so
they only have to do it once.
Yeah. So in general, designers tend to go for the unit which is certified because first of all, it's actually easier, right? They save time and energy to try to get the data somewhere else when they have those data already in PHPP.
Yeah.
And also there is this quality assurance, right? Okay, it has been certified by PHI, so if in PHPP we see, okay, it performs like this and this, we can expect that it will be like that.
Yeah.
But if you use those data from the producer, as I said before, which has been measured in different, maybe they don't necessarily correspond to the real operation.
Yeah.
I mean, that it's a big challenge.
Approximately, can you give us some numbers? How many different products you've got on the database now?
Well, I mean, we certify different types of heat pumps. And so, for example, we have this compact unit, as you probably know. It's a combination of ventilation, heat pump, and domestic hot water preparation. And I think, there are like 10 of them. And then there are many units are certified in China. And those units usually don't have domestic hot water. It's just the ventilation combined with heat pump.
Right.
So we call it like a combi unit.
Yep.
But still connected, the connection of ventilation and heat pump. I don't know, we have also like 10 or 12 of those.
Yeah.
And then there is only one air-to-water heat pump, big certified in Europe. It's in Spain. It's a Panasonic unit. So those standalone heat pumps, that's the challenge to get them on board, really.
Right. So just the air-to-air.
Yeah.
You don't have any of those. Wow.
Yeah.
Well, the opportunity's there for some people.
Yeah, I think so.
Are you also looking at different refrigerants? Is that starting to be a topic of, because I know people are starting to look at
they're looking into
alternatives.
CO2, but that's a bit different story. That's a different heat, different type. Actually, it operates in different way, with different temperature. And I know that producers talk about it a lot, but I don't know any details actually, because for me, at the end of the day, when we certify the unit, we evaluate how it performs. Yeah. And if it runs with refrigerator A, B, or C, I mean, it doesn't really influence this.
Right.
Of course, there is this issue with the global warming potential of refrigerants, right? But, to be honest, I haven't looked into this. Well, I was not too interested in this. I mean, and at the end of the day, I can influence somehow producer, or we can try to push them to have the certain type of products at certain size with certain performance. But how they achieve it, it's really job of the engineers within the company. It's not me to come to them and, hey, you should use this refrigerant or that. I mean, it would be a bit, I don't feel like that's our job, actually.
Yeah. Looping back to the problem of oversizing, over-specifying, why is that, and what can be done about it?
Well, why is that? It's very easy, because they simply have been designing products at certain size for last, let's say, decades.
Right.
And the buildings 20 years ago mostly had higher heating loads and cooling loads. So there was a need for this size of the units.
Right. So they're doing it.
Now we want them to reduce it.
Right. So they're not looking at natural loads. They're looking at the sort of size of the building and thinking, this looks about right. Yeah.
I mean, the situation, there are two challenges, I think. one challenge is that they monitor what we do very closely. That's what I can tell you.
Yep.
I mean, it's not that when I go to the producer and speak and offer our services, our certification, it's not that they don't care or anything. They already know very often, and they check what we do.
Right. Yep.
So I think they check the market. Maybe they just feel like, because as a producer, you want to jump on the wave when it's already there, right?
Yeah.
You don't want to be built. You don't want to be necessarily the one who builds the wave, because that's a lot of energy.
Yeah.
And
that's expensive.
Yeah. You want to be there when momentum is there already, but not too late. So you check what happens on the market, and maybe their feeling is that the market is still too low.
Right.
But I'm speculating here.
Yeah.
Okay. That's not that I would be told. This is my impression. So they are kind of all waiting on the sidelines. When the time is right, they jump in. That's my impression. Another reason, again, that's just my impression, or one of the hypotheses, let's call it, is that, of course, what we do in Passive House, we reduce the size of the product.
Yep.
Therefore, it should be somehow cheaper.
Yeah.
But the producer wants to sell the bigger products because he can have more profit, he gets more profit from that. Yeah. So it's a bit demotivating in that matter. If you look just for the profit, if you just for on your economics, and you don't see the the whole point why we do it, behind it, and if it doesn't resonate with you, it's like, whatever you do there, I'm here just to sell the unit.
So you're asking them to pay more money to get tests that show that their systems don't perform as well, and they're going to sell smaller ones.
I wouldn't formulate it like this, because their system already perform as it perform. It will be documented in a bit different way, and maybe, unfortunately, one could get this impression that it's not the case. But that's why we need to communicate this properly, that even with the producer, it's like, you need to communicate that if you have like here seasonal performance factor following one particular norm, and then PHI, okay, those are different, but you need to communicate with your customers that those two are not to be compared. Right? Yeah. And if you make share, then it's just
I think that's
the way
right.
how you communicate.
It's totally, and that's so it's communication and education for the industry. And it sounds like those services engineers need. But training as well.
But you can probably now understand what the challenge is, right? That it's like how to. So what I think is very important is, because what I can do as a certifying body, I can do my best to go to the producer and present in the best way I can what we have to offer and what are the benefits. But he sees me still as somebody who will profit on this somehow. So that's one part. What we need, and I think it's crucial actually, after last few days when we had discussions with our affiliates and course providers and other designers, I feel like that was kind of, we agreed on this, that it's very important at that particular area to be active and not necessarily push the producer, but inform the producer, like, look, there was this project now. We needed to import a unit because yours is not certified. Look, there are 2 more projects in the pipeline. Are you interested? Like to show him that there is a business case for him. Because I can also talk about this, but it's like, it's
so
like, he can think like I'm doing the best just to sell my certification. But if this comes from the another side, if this comes from the developer, let's say you have one big project, right? Then, then they will listen because they feel, they smell the profit there, so to say.
Well, it's more of a partnership rather than you just being the bad person who's, marking them down or rating everything. You're sort of offering that opportunity to the
I can present them with the opportunity or with the options there are, but the demand needs to be communicated by people who actually buy the product. Because those are the clients, those are the customers, right? I'm not buying the unit. I offer something which I believe can help in already today and near future to the producer to sell the units if they perform properly and if they are proper size. And I mean, there are benefits to it, but there is always this. I think it's just they wait on the sidelines and
catch that wave.
Yeah.
Where do you see things happening, going, say, in the next 5 years with heat pump technology and the market in general?
I don't think I can answer that question because I don't like to speculate in the way that, when you look what happens in the world today and last few years, it's difficult to see if there, it would be speculation, pure speculation.
It seems
very often we are also on the peak. My feeling is it has a lot to do not with the available technology only, but with the finances and stuff like that, mortgages. Until now, it was very low, the mortgages. 20 years, very low. We got close to the zero, right? So everybody was building. I think it's over.
Yeah,
this is changing already now. So if there will be higher interest rates in the future, this will influence the whole building sector. Yeah. Not only building sector, but the building sector is very important for the economy because there is a lot of money, all the mortgages and stuff like that.
Specific to heat pumps though, there is definitely a big drive to electrify, and that's pushing a lot of people. Yeah,
I think that's the big push. Yeah. That's true.
And also something that we're hearing a lot about during this conference is building and designing in warmer climates where heat pumps are a good solution, possibly a required solution. I know that where I am in Australia and New Zealand, most passive houses will probably put in a heat pump for cooling as much as for heating. So I can see a lot of growth in that in demand. Yeah.
I mean, as I said, it's a bit. I rather talk about things which happens,
stuff
exactly, because otherwise we speculate about what can happen. I can see there is this push, right, to electrify, and now even more with this issue with Ukraine and Russia conflict and all the sanctions and stuff. But I'm not getting political here, so.
But I guess what it does point to is the importance of the work that you're doing and you're having that data and increasing people's understanding of what they're looking at. And it's great because without the work that you're doing in PHI, that stuff wouldn't exist really.
I think we have something to offer. That's what I think. I mean, we are ready. We are there. It's just the way we really need to focus more on how to approach people and maybe the ways we can approach the people. Yeah, because one thing is to have the solution ready, but you need to, deploy that solution.
Yeah. Hey, well, thank you. Thanks for your time today. But also
you're welcome.
For all your work. I've been watching some of your. I know you've been talking about this and doing it for 6-7 years now. So
years.
It's good. It's important work. So keep it up.